I see my screen? Yes? All right. So, yeah. So, like I was saying, when we're talking about matter, matter is anything that is around us. So, anything that has mass and occupies space, that means something that has volume, that is considered as matter, right? Now, matter is made up of atoms, molecules, and ions, right? Can somebody tell me what are atoms, what are molecules, and what are ions? Or what is the difference between all three? Any, whatever you know. What are atoms first? Let's talk about what are atoms. Hmm? Put it down in the chat box, please, Naisha. Atom. They are building blocks of matter. Okay. How are they different from molecules then? How is matter different from molecules? Okay, matter is made up of tiny particles called atoms, correct. Yes, what is the difference between atom and molecule? Okay, atom everybody knows. Atoms are the building blocks of matter, or atoms are the most tiniest particles of matter. And you cannot break down an atom further. Correct, Naisha and Garansh, both of you. Two or more atoms can give you a molecule. Okay, so for example, we have atoms of, let's say, oxygen, hydrogen, right? And if I combine them together, I can get a molecule of water. So this is one molecule of water, which has two atoms of hydrogen and one atom of oxygen. Okay, so this is a molecule. What are ions now then? Anybody? What are ions? Any idea? It's anything that you know of. Put it down in the chat box. Okay, not sure. All right. Okay. Now what happens is, if we look at, understand this, no need to copy anything. Just sit back, relax, and see what I'm telling you. Understand. Atoms are made up of certain subatomic particles. Okay. Subatomic particles mean that inside the atom we have small little particles. All right, these subatomic particles are of three types. We have protons, electrons, and neutrons. Okay, protons have positive charge, electrons have negative charge, neutrons are neutral, no charge. All right, now inside the atom, we have a structure called the nucleus. Okay, so this is, let's say, the nucleus. Inside the nucleus, you will have protons and neutrons present. Around this nucleus, the electrons are always vibrating or orbiting the nucleus. Okay, so you have electrons here, electrons, depending on how many electrons does the atom have, you can have that many number of orbits. Till here, any doubt, anyone? In an atom, the number of electron will be equal to the number of proton will be equal to the number of neutron. Okay. So for example, the number, if an atom, that's what, the atom doesn't split only. All right. Atom is the tiniest particle. So we cannot break it down further. If we are breaking it down further, it will not exist to be an atom. So we don't split an atom. All right. Now, how do you know what is the number of electrons, protons, neutrons? That we have found out, that is called atomic number of the atom. So everybody has seen the periodic table? Yes. The elements are arranged in a certain way, and you must have seen there are numbers written on the elements 1, 2, 3, 4, 5, 6, like that. Those are all the atomic numbers. So, according to the atomic number, we have made the periodic table. Okay. So, for example, let's say the atomic number of hydrogen is 1. Okay. So, that means how many electrons? For hydrogen, atomic number is 1. How many electrons? 1. How many protons? 1. How many neutron? 1. Okay, so that means around in the nucleus, if this is your nucleus will have 1 proton, 1 neutron, and around the nucleus in the orbit, like imagine it like how, the planets are orbiting the sun. Similar to that, you will have only 1 electron, 1 orbit, like this. Okay, now let's say sometimes what happens is certain atoms, they cannot exist in this form. That means hydrogen cannot exist in a single electron form. It has to complete the orbit. So it takes it from someone else. Okay. So to complete the orbit, what happens is the first orbit should have 2 electrons, and rest of the other orbits, if there are more, then they should be 8. Okay. So how many are there in hydrogen? So this is your hydrogen atom. How many electrons there in hydrogen atom? In the first orbit, 1, right? How many does it need to complete its orbit? It's the first orbit only. Hmm? How many more electrons does it need to complete its orbit? 1 more. Yeah. So how will it get 1 more? It can get 1 more from another atom. And that is how molecules are formed. When they're sharing their electrons or when they're giving their electrons to each other. All right. Now, when they give electrons to each other or when they're sharing electrons, only electrons can move here and there because protons and neutrons are present inside the nucleus. They cannot come out. So if something gives away its electron, all right. So let's say if an atom had, let's say oxygen has 8 electrons and it gives away or it takes 2 electrons from hydrogen in case of water. 2 electrons are coming from hydrogen. So now number of electron becomes 10, number of proton is still 8, and number of neutron is also 8, correct? That means oxygen now has 2 extra electrons. Yes? If it has 2 extra electrons, can I write it like this? Oxygen has 2 extra electron charge or negative charge. Hence, this is known as a negative ion. Any doubt here, anyone? It has 2 extra electrons. So compared to proton and neutron, neutron has no charge, so it doesn't matter. But proton has a positive charge, so more apart from 8, it has 2 more. So it becomes 2 minus, or we write it as O2 minus. That means this is a negative ion. Any doubt here, anyone? You can put your doubts in the chat box if there are any. If something is giving away its electron, then it becomes positive. So if I have, let's say hydrogen can give away this electron, it becomes H positive. So this is a hydrogen ion. All right. Put in your doubts. Vatika, what did you not understand? Ion? Okay, sorry guys, I lost connection. Can you guys see my screen? Okay, Matika. I'll just explain it very clearly. We have equal number of electrons, protons, and neutrons, right? Neutron has no charge. So we are not considering neutron. Proton and electrons are the one. Protons have positive charge, electrons have negative charge. Okay, till here everybody's understood. Now let's say I have extra electrons. Okay, so I'm giving my extra electrons to somebody. If I'm giving away extra electrons, number of protons are remaining the same only, right? So let's say I have, so let's say oxygen has 8 electrons. To complete its orbit, it needs 2 more. So it's taking 2 extra electrons from hydrogen. All right. When it is taking 2 electrons from hydrogen, number of electron becomes 10, proton is still 8, and neutron is also 8. Right? So how much is the extra charge on oxygen atom now? 2 extra charge, right? 2 negative charge. So that's why I'm writing it like this. O, 2 and negative charge. That means this will indicate that this is a negative ion with 2 electrons extra than the normal. Okay. Now let's say hydrogen is giving away its electron, no? So hydrogen had only 1 electron, one it is giving to oxygen, another hydrogen is also giving it to oxygen. Okay. So hydrogen now has how many electrons? Electrons become 0, proton is 1, neutron is also 1. So positive charge is more, right? So this becomes a H plus ion, and this also will become an H plus ion. This is what I'm talking about, water. Okay. That is why the formula of water is H2O. So 2 hydrogen atoms are required, 2 hydrogen atoms and 1 oxygen atom. This will form your water molecule. So these positive and negative charged atoms are known as ions. So either they can share their electrons or they can completely give away their electron. That depends upon how reactive or how non-reactive any atom is. So in the periodic table, the ones that are present right in the beginning, they are the most reactive. So they give away their electrons easily. Okay, they don't share. They give it only. They say take it and go. Okay. The ones that are at the back, that means the non-metal part, the ones that are at the end of the periodic table, they are unable to give away their electrons easily because they have a lot of electrons. So what they do is they share. They say something you share with me, something I will share with you, like that. Okay. So they share their electrons. Got it? Ions. So this is how molecules are also formed, because we have other chapters where you will have formation of chemicals and formulas and all of that. So this is what you have to know. Okay. All right, let's move forward now. This, of course, when we come to regular classes, we'll do in more detail. So these are the topics that we're going to cover in this chapter. So we have matter, states of matter, characteristics of matter, distinguishing properties, classification of matter, physical properties of matter, what are mixtures and pure substances, what are the different types of mixtures, different properties of mixtures, why do we need to separate them, and there are different methods of separation. So this is all sorting, and then this is separation. Okay. So matter, we've already said, matter is everything around you. It is defined as something that has mass and takes up space or has volume. Okay, could you name 2 things that are not matter? Put it down in the chat box. Send me a direct message so that everybody answers. Direct message, please, everyone. So that I know that, everybody's answering and not just copying each other's answers. Okay, Matika, very good. What about others? Okay, Saransh, good. I want at least 1 from everyone. Saransh has given me, Matika has given me, Shobhamita, Suryansh, Naisha. At least 1. Suryansh, very good. Correct. Okay. So time, sound, any kind of energy, gravitational force, heat, darkness, thoughts, emotions, defeat, they are not matter. Very good. Okay. Now these are the different states of matter that we are going to cover. There are mainly three states of matter which we will be talking about in terms of different properties and how we are separating them and how what kind of materials are present. But in total, we have five states of matter. Okay. And how do we sort them out? We sort them out on the basis of their appearance. That means what is the color of the substance? What is the texture? Is it smooth? Is it rough? Is it hard? Is it soft? Does it have luster? Luster means shine. Solubility. Is it soluble in a solvent, especially water? Is it soluble? Is it insoluble? Whether it's a metal or non-metal. So metal and non-metals are again divided on the basis of their reactivity. Okay. So again, in the periodic table, after the class, what you can do is you can have a look at the periodic table and you will see the ones that are present right at the beginning. They are metals because they are highly reactive. They can give away their electrons very easily. That is why metals are good conductors of heat, good conductors of electricity, because they give away electrons easily and they form positive ions. Non-metals, on the other hand, do not have any like they do not give their electrons easily, hence they are less reactive. Then depending upon how much light passes through any material, so we have opaque, translucent, and transparent. So we'll talk about each one of them in a little while. Now these are the five states of matter that we have. So solid, liquid, gas, everybody knows, right? Solids like this, there is no intermolecular space between the atoms. All right. And if you see here, the atoms are moving a little bit, right? They are vibrating. Why are they vibrating? Because each and every atom has some kind of kinetic energy in them. All right. Where is that kinetic energy coming from? Yes, tell me where is the kinetic energy coming from? I'm saying all the atoms in each and every state of matter, whether this is solid, this is liquid, and this is gas, right? They are moving, right? You see the particles are moving, vibrating a little bit. Why? Because they have some amount of kinetic energy in them. Why do they have kinetic energy in them? Any idea? I just told you that inside the atom, the electrons are rotating around or revolving around the nucleus, right? So when electrons are moving, the kinetic energy is coming from those moving electrons. So even if the solid particle does not change shape, the molecules or the atoms are slightly vibrating around the mean position. Okay. Now what happens is when you apply heat, we see here it's written as the temperature increases, solids convert to liquids, liquids convert to gas, gas convert to plasma. And as the temperature decreases, plasma converts to gas, gas converts to liquid, liquid converts to solid. And we also have Bose-Einstein condensate. We'll talk about plasma and Bose-Einstein in a little while. So what is happening? Molecules are like this. Okay. So imagine these are two atoms of solid. They are vibrating. You apply heat. Heat energy converts to kinetic energy. What happens? They start moving faster. More heat is applied, more faster. The more they move, the molecules will move apart from each other. And as they move apart from each other, they will change state. So solid converts to liquid, liquid will convert to gas because they are gaining kinetic energy because of the heat energy that is being applied to these molecules. Got it? Yes, no, don't know. I see blank faces on the screen. Give me a thumbs up if you've understood. Okay. All right, great. So we have solids, liquids, and gases. Apart from that, we have something called the plasma and the Bose-Einstein condensate. So what happens is solid molecules have very uh, less intermolecular space between them, and the force of attraction between the atoms or the molecules is very high. Coming to liquids, liquids have slightly more space between the molecules, and the force of interaction between the molecules is lesser as compared to solids. As we move to gases, Gases have the least amount of intermolecular attraction, but they have the maximum amount of space between them. Now, plasma is gases at very, very high temperatures. So they can gases that exist at more than 5,000 degrees Celsius. Okay. Why? Because they have a lot of ions in them. So they have charged particles. Those charged particles have a lot of energy. Okay. And that energy is then dissipated out as heat and light. So all your stars, sun, they are made up of plasma. Okay. Now coming to Bose-Einstein condensate. Bose-Einstein condensate is something that we have made. It's man-made. So normally when temperature decreases, what happens? When temperature is decreasing, gas will convert to liquid, liquid will convert to gas, solid. But Bose-Einstein condensate is a type of gas that can exist at very, very low temperatures. So using the Bose and Einstein formula, we have been able to stabilize gas at this low temperature. All right. Okay. So Bose-Einstein condensate, we have no practical use of it as of now, but we have discovered it. Like we have been able to stabilize a gas that is this low in temperature. Any doubt here, anyone so far? All right. So like I said, what happens is when the temperature of the system goes up, the matter in the system also becomes more excited and active. That means more kinetic energy is increasing, and then the change of state of matter occurs. All right. Of Bose-Einstein, you're saying, Saransh? Bose-Einstein condensate is only an example, actually. Okay, it is a simple, like a gas that has been able to, we've been able to stabilize it in the low temperatures, minus temperatures. Okay, so here you can see as solids gain energy, it converts to liquids. Liquids gain energy, they convert to gases. Gases gain energy, they convert to plasma. Okay, so temperature will increase, solid will convert to liquid, liquid will convert to gas. Vice versa, gas, temperature decreases, gas will convert to liquid, liquid will convert to solid. Now, the point at which, this is specifically for water, the point at which the liquid converts to solid is known as the freezing point. Okay. So the freezing point of water is what? Freezing point of water is 0 degrees Celsius. So at exactly 0 degrees Celsius, you will have water being converted to ice. Okay. Plasma, Shubhmita, I told you, plasma is when gases exist at very high temperatures. When gases have ions and all. We saw it here like this. Yeah, this one I was telling you about. Gases at almost 5,000 degrees Celsius. That is plasma. Okay. All right. Any doubt here, anyone? Okay. Then we have liquid converting into gas. So the point at which liquid converts into gas is known as the boiling point. All right. Now, when we have the boiling point of water, the boiling point of water is 100 degrees Celsius. All right. Any doubt, anyone? Slight network issues. I'll keep my video off for some time. I'm trying to reconnect to a Wi-Fi. All right. Any doubt, anyone here? Temperature change. So boiling point of any liquid or any material will be different from each other. That means, let's say water is boiling at 100 degrees Celsius. Alcohol boils at 75 degrees Celsius or 77 degrees Celsius. All right, depending on the different types of alcohol. So not every material will boil at the same temperature. Similarly, freezing point also will be different for different substances. So for water, I've already told you, for water, It's 0 degrees Celsius freezing point and boiling point is 100 degrees Celsius. Yes, Naisha, what's your doubt? You can put it in the chat box. All you have to remember is that as we apply heat, heat will be converted into kinetic energy. Okay? When kinetic energy is going into the molecules, right, the molecules will move apart from each other, like I told you, because they are vibrating more and they will create more intermolecular spaces between each other, and hence there will be change in the physical state of matter. What is the point when solid changes to gas? um, Naisha, there are very few molecules or very few substances that directly convert into gas. So there is no particular temperature. It depends upon, again, material to material. It's not called anything. The process of conversion of solid into gas is known as sublimation. Sublimation. Okay. But there is no particular like point, freezing point, boiling point, because very few materials do that. Okay. Any doubts so far, anyone? We will talk about those state change in states of matter, like what are they called, in a little while. Okay. Yeah, like naphthalene ball, correct. Okay. So other than temperature change, even pressure can create a condition in which there can be change of state of matter. Normally for gases, what happens is, normally in gases, we have, yeah, no problem, Saranj. I'll tell you the spelling. Don't worry. So normally what we have is when we apply pressure to certain materials, okay? So for example, let's say we have gases, right? And we apply pressure to the gas. What will happen? Gas molecules are far apart from each other and you're applying pressure. So they will be forced to come close to each other. So when they're being forced to come to close to each forced to come close to each other, what will happen? They will change state. And that is exactly what is your LPG gas. The gas that you get at homes, the gas that is coming for cooking and everything, that is your LPG, full form, liquefied petroleum gas. So gases are put under pressure, they are liquefied. Why? So that they're easy to transport. Of course, obviously, liquid is easier to transport than a gas, right? It's easier to transport, and the moment you switch on your stove, what happens? Pressure is released. That is why it comes out as gas. But in your cylinders or your main supply, it is in liquid form. It's pressurized. Liquids can also be pressurized to a certain point, but solids cannot be pressurized. So anyway, solid cannot be changed into a much more compact structure. So gases, when pressurized, will be converting into liquids. Liquids, when pressurized, can be converted into compact molten-like material. They don't convert into solids, but they convert into molten material, slightly thicker material. Okay, so pressure can change the melting point of certain substances. Melting point is the point at which solid will convert into liquid, right? Where there is yes, correct. The moment there is release of pressure, they'll convert back to gas because the molecules are forced to be together. No, the moment pressure is released, they'll go back to being their original state. So they go back to being there in the gaseous. All right. All right. So pressure will change the melting point. Why? Because you're anyway pressurizing it and bringing it closer, right? So the moment you bring it closer, the melting point changes. All right. Any doubt here, anyone? How it changes, what it does, that we'll discuss in the regular classes. Okay, so this is what you need to know. All right, these names. So when gas is converted into plasma, it is called ionization. When plasma is converted back to gas, it is called recombination. Gas converting into liquid is condensation. Liquid converting into gas is vaporization or evaporation. Okay, I'll tell you 1 second. Liquid converting into solid is freezing. Solid converting into liquid is melting. Solid directly converting into gas is sublimation. Gas converting into solid is deposition. Enthalpy means enthalpy of a system. So now since it's given, but you don't need to know this for now. but I'll just explain a little bit. Enthalpy means the change that is occurring in the system. So, like the molecules are always moving, right? So, since they're always moving, there is some or the other kind of change always happening. So, enthalpy means change. That much you need to. Deposition, Naisha, sometimes what we do is to obtain pure crystals of salt. We will vaporize the salt and then directly convert it into solid. So that is deposition, gas into solid. So we'll heat up the mixture. All right. So let's say you have salt and some sand particles in the salt. We will heat up the mixture. Sand particles will be left behind. Salt will vaporize. And then that vapor will be directly converted into crystals of solid salt. So we obtain pure substances. Recombination and ionization is the conversion between gas and plasma. So plasma is what? Plasma is gases at very, very high temperature, right? So when gases are converted into ions, so the particles in the gas, when they convert into ions, we get plasma. And when ions combine together, that is recombination. They are recombining together and giving you atoms of gases. So plasma will again form gas. Any doubt here, anyone? All right, now quickly, I'll just explain this, and this again, whatever is remaining, we will do in the enthalpy meaning. I already told you, Shobhamita, it's the change, any kind of change that occurs in molecules, that is enthalpy. Gas is normal gas like air. Plasma is gas at very high temperatures, and it is existing at high temperatures because it has ions in it. So those ions are highly reactive, hence they exist at very high temperatures. So your stars, sun, they're made up of plasma. Okay. All right. Now matter can be divided into two types: mixtures and pure substances. Pure substances are divided into further two types: compound and element. Mixtures, we have homogeneous and heterogeneous. I'll come to mixtures in a little while. Let's talk about pure substances first. Matter that cannot be physically separated is a pure substance. Okay, so pure substance, we have an element and a compound. So, for example, oxygen, hydrogen, nitrogen, they are all elements. You cannot break them down further. When these elements are combining together, they give you a compound. H2O is a compound. NaCl is a compound because they are made up of two or more elements. So compounds again cannot be separated out physically. They can only be separated out chemically. That means if I have H2O, which is water, if I start heating it up, it will not break into hydrogen and oxygen, right? It will remain water only. It will simply convert into vapor form. So elements are the basic structure of any atom. When two or more elements combine together, they give you a compound. Both elements and compounds cannot be separated out physically. Elements cannot be broken down further into simpler units. Compound, on the other hand, can be broken down into elements, but only chemically, not physically. Okay. Any doubt in pure substance, anyone? Pure substance, any doubt, anyone? Yes, no? Shall we move on to mixtures then? Okay. So next we have is mixtures. Mixtures is something that has no fixed ratio. Pure substances have a fixed ratio. That means if you have water, whether water is in the solid form, that means whether it's ice, whether it is in the liquid form, or whether it is in the vapor form, it will remain H2O. That means two molecules of hydrogen and one atom of oxygen, right? But in case of mixtures, mixtures are not present in fixed ratio. That means, let's say I want to make lemonade. I can take any amount of water. I can take a bottle of water. I can take a glass of water. I can add one lemon to it. I can add two lemon to it, or I can add 10 lemons to it. It's my choice, right? There is no fixed ratio of that. I'm coming to that, Naisha. I've not come to heterogeneous and homogeneous yet. And Saransh, you can chemically, different compounds have different chemical reactions to be separated out. So if let's say you're talking about water, water can be separated out by passing electricity through acid. Like we mix water with acid and then pass electricity through it. Only then it can be separated to hydrogen and oxygen. Different compounds will have different chemical reactions. Okay, coming back to mixtures. So mixtures do not have a fixed ratio. I can mix them in any which way I want. So they can be physically separated out. Okay. We have two types of mixtures, homogeneous and heterogeneous. Homo means same. Hetero means different. So homogeneous mixture, when we have any homogeneous mixtures will be in the same phase. That means you will not be able to make out the particles of the mixture. So let's say I have a glass of water and I add salt to it and I stir it. Eventually salt will mix in water, right? So I'll get a homogeneous mixture of salt and water. I will not be able to see salt and water separately in the mixture. Okay. So you cannot see the parts. Heterogeneous mixture is a mixture where all the parts are separate. So you can see the parts easily. So example, I take a glass of water and I add sand to it. So sand, even if you stir it, the sand will not mix in water. So it's a heterogeneous mixture. Okay. Any doubt, anyone? Both of them can be separated out by physical methods. What are those physical methods? How are we going to separate them out? That we'll discuss in the regular classes. So that is the major part of separation. So separation of mixtures is what is mainly in this chapter. Any doubt in what is heterogeneous and homogeneous mixtures? Anyone? Okay. One example of homogeneous and heterogeneous mixture. Can you give me? Send me a direct message. One example of homogeneous and one example of heterogeneous. Whatever comes to your mind. Let's see if you've understood or not. Quickly put down, but send me a direct message, please, so that everybody can answer. Quickly, quickly. I want answers from everyone. One example of homogeneous, one example of heterogeneous mixture from your side. Okay, Naisha, correct. Correct, Saransh. Suryansh, correct. Heterogeneous, can you give me something else? This example I only gave you. Naisha, correct. Okay, correct. Motika, something that another other than this I've already told you example. I only gave you salt and water. Any other example other than salt and water? And one heterogeneous also I want. Okay, heterogeneous correct. Suryansh correct. Okay, very good. So heterogeneous and homogeneous, everybody has understood. Homogeneous mixtures will not be, you will not be able to see the parts. Heterogeneous mixtures, you will be able to see each and every part clearly. So I'm going to stop here today, okay, for this demo. All right. Any questions for me, anyone, if you have any questions regarding the classes or anything else? No? All right. Great then. Thank you everyone for joining. I hope you liked the demo. I'll see you guys in the regular classes hopefully soon. Okay. Bye everyone. Have a great day. Welcome. Bye bye. See you.